Hey explorers, I've got a mysterious alien-looking captivating magnetic ooze to study today. It's called Ferrofluid, a version of which you can make at home, and we're going to walk you through it, as well as discuss some really cool real-world applications. Ferrofluid is a colloidal suspension of iron filings in oil, which takes on a dual personality. If left by itself, it's a liquid that goops and slides around whatever container it's in. But when exposed to a magnetic field, all the iron filings condense and become solid. They even take on the shape of the magnetic field itself. Ferrofluid was first tested in 1963 by NASA scientist Solomon Steve Papel, an ex-Army Air Corps navigator turned mechanical engineer. He added magnetic dust to rocket fuel, proposing that the fuel could be guided into the necessary chamber in zero gravity using magnets. While it never took off, some other great uses were discovered. Today, we're going to take a look at making a version of Ferrofluid at home. A list of supplies and instructions can be found in the video description. And while you're there, take a second to subscribe to Clayton's Exploration Station so you don't miss any of the fun. To make a version of Ferrofluid at home, we need a short list of items. Latex gloves, a container and stir stick for our fluid, iron filings, oil, and a rare earth or Neodymium magnet. Latex gloves are important because iron filings are actually very hard to get off of skin, which I discovered the hard way last night while running some tests. Do your best to not touch the Ferrofluid and try not to make a mess, or you could be dealing with the cleanup for some time. Nothing like some latex gloves. Iron, represented on the periodic table with the symbol Fe, is the most common element on Earth. It's even in our blood, except Walter's. It's magnetic, it's a pliable metal, and it's used for so many different things that we use every day. We'll use nano-sized iron filings in order to give our Ferrofluid its magnetic properties. Next is our motor oil. There are a lot of different oils you can use to try to make Ferrofluid, but motor oil yields really great results. This is because it's not only a carrier for the iron filings, but a surfactant that stops the filings from clumping together. Neodymium, found on the periodic table with the symbol Nd, is a rare earth element used as a compound to make what is called a rare earth magnet. This is going to be the magnetic field that we expose our Ferrofluid to in order to give it its shape and pattern. With our latex gloves on, it's time to make our Ferrofluid. In the video description, you'll find a recipe for a small amount, but for our purposes today, we're going to make more so we can see what happens. This recipe needs equal parts by weight, iron filings and motor oil. So we're going to start by taking our container and pouring in some of our motor oil. Using our scale, we can see that we weighed out 155 grams of motor oil. So now we just need to add to that 155 grams of iron filings. Again, very messy, be very careful, and we will see the difference in weight as we scoop little by little into our container. Gonna take a moment, stir this bit in. All right, you can already see it starting to thicken up as the oil suspends the iron filings, but still very liquidy, which is not what we want. All right, so we are at 195. We're gonna put in a couple more scoops. So the weight target that we're getting to is 310 grams of combined iron filings and motor oil. Right now we're at 224. And we're getting to a nice viscosity too. All right, just giving it a good stir. Again, because this is a suspension, the iron filings and oil won't actually combine and become something new. They're actually just existing in the same place. Because Ferrofluid is a suspension of iron filings in oil, this is what gives it its two distinct states of matter, liquid and solid when exposed to a magnet. This is very similar to another experiment we did with a non-Newtonian fluid where we made an ooze. All right, we're at 277, just trying to get to our 310. Definitely a lot more viscous now. Still seems pretty liquidy, but it should until it's exposed to a magnet. All right, we got this really cool alien looking black goop now. We are at the correct weight now, but it still seems kind of liquidy. So we're gonna apply a magnet to it, see what happens, and if we need to, go back and add a little bit more of the iron filings. So we're gonna get our Neodymium magnets, or rare earth, and we're going to put it to the side of the jar. So it's right now just looking like a blob, like it's still too liquidy. So I think we need to go back and add a little bit more of the iron filings.
Science! Fails.
We're gonna do 2 scoops because it is very runny still. All right, now we'll mix this in. Turning into a bit more of a paste now. The motor oil does do a really good job of keeping the iron filings dispersed throughout it instead of clumping up all in one place. We did a smaller version of the experiment last night using canola oil and iron filings. It didn't quite work out as well because the oil didn't keep the iron filings separated, so they all sort of clumped together in one place. But it is actually a really good way to show out what Steve Pappa was going for in keeping liquid in a container, just like this, inside that container, even when it's in 0 gravity. We've mixed in 2 more scoops of our iron filings into our oil. So now we get to apply our magnet again, and it is much less goopy, but still not quite taking on the rigid patterns that we should be seeing with a ferrofluid. When a magnetic force is applied to a ferrofluid, you should see spikes and cones. These keep their shape because of the surface tension of the oil, but they are the little tiny nanoparticles of iron filings solidifying, which we're just not seeing too much of here. Little bits. I'm gonna try my other magnet. Oh, here we are. I do have a stronger rare earth magnet, which is definitely doing the trick and creating some of these spikes that we should be seeing from our process. Ooh, oh, that's cool. I've added more iron filings to my ferrofluid, but it still seems a little liquidy, like it has too much oil in it. So instead of adding more iron filings, I'm just gonna use a paper towel to dab up some of the excess oil. Again, this is something you wanna be really careful about. You don't wanna just dunk it in, because then you're just gonna be picking up a lot of those iron filings. You're just trying to go around the edges of your container just to get the excess oil. This isn't always a necessary step, it's just because I've noticed some extra oil in mine. As you can see, when a magnetic force is applied to the ferrofluid, a pattern develops and you can move the fluid around. It shifts and moves as you move the magnet. Doesn't even necessarily need to touch the container, it's just enough if the magnetic field touches the fluid. The pattern that you see when your ferrofluid is exposed to a magnetic force depends on 3 things: the amount of ferrofluid you have, the shape of the container it's in, and the strength of the magnetic force. It's really, really beautiful stuff. As for the practical applications of ferrofluid, just in the last 40 years, it has been used as liquid seals in computer hard drives where the liquid is kept in place by magnets. In the last decade alone, it has been used in biomedicine, liquid robots, environmental remediation, and vehicle suspension systems, just to name a few of the many ways that ferrofluid is used. In the world of biomedicine, there's exciting research that shows that ferrofluid can be used to kill cancer cells, fight drug-resistant infections, and even help neurons in the brain communicate with each other. With an even more seemingly futuristic path for this substance, there is currently in development liquid micro-robots that will be able to shape-shift. If you've ever seen the Terminator movies, think of the T-1000. Environmental applications are being researched as well, including cleaning up some of the microplastics in bodies of water that are being polluted by these damaging substances. Some such research is even being funded by Iron Man himself, Robert Downey Jr. Ferrofluids are even being used in vehicle suspension systems to allow shock absorbers to react to real-time changes in varying conditions. These are called magnetorheological dampers, and they're filled with ferrofluid controlled by electromagnets. Invented by General Motors Delphi, the first vehicle to use such dampers was the Cadillac Seville STS in 2002, but these dampers can now be found in vehicles such as the Shelby GT350 and the Lamborghini Huracan. When you're done observing the effects of a magnetic field on your ferrofluid, if ever, make sure to put it in the garbage, not down your pipes. This will clog and damage your plumbing. This also isn't something that should just be flushed out into the environment. Ferrofluids and the research with them should be used to clean up the environment, not pollute ecosystems. Alright explorers, that's the experiment for today. If you need me, I'll be playing with ferrofluid for the foreseeable future. Stay curious, explorers.